Hello everyone! So here is our next section in chapter 2, and this section is 2.2 inductive and deductive reasoning. And that's all this section is about, those two terms. So that's what we're going to be learning. And then we have just 3 vocabulary words. So get your notebooks ready, get your flashcards ready. We have a little short section to go through in this video. So the first thing that we're going to talk about here are definitions. So what is a conjecture? Let's see here. It says conjecture is an unproven statement based on observations, okay? Strictly based on observations that we're observing and making note of, recording what we're seeing, but it's all based on what we're seeing. That's what a conjecture is, okay? After you observe something, you can make a statement about what you observed. Now, a conjecture is going to be used when we do inductive reasoning. Inductive reasoning is when we form conclusions based on patterns we observe, and then we write a conjecture. Okay, we observe the pattern, and then I can make a statement about what we observed. Okay, so what this is going to look like in an example, let's take a look here. It says, explain the pattern you observe. What is the 4th term in each sequence? So if we look at the stars here, I'm just observing them. I notice at first everything is shaded but this lower right point of the star. Then it's the lower right one and the one counterclockwise to it that's unshaded. And then it kind of kept moving. So I observed that happening three times. So my guess is that that's going to keep happening. Each term has one last point of the star shaded. So that 4th term is going to keep on moving counterclockwise, unshading the points of the star. Okay, and that's my conjecture. Let's take a look at the second one. So it starts with 1 circle and then 2 more circles below that 1 circle. And now I have 3 more circles below the previous one. So I can summarize my observation like this. Each term has another row added to the bottom with 1 more additional circle. So notice now I took the one before it, 3, with on the bottom, 3 circles on the bottom. I added 1 more to it and created another bottom to the circles. Okay. All that is just I was performing inductive reasoning, taking in what I've observed and writing a conjecture about it. Okay, a little bit more on that is here's another example. What we want to make sure we know is that we need enough information in order to make a conjecture. Check out this example: 1, 3. Okay, what's next, right? Who knows? Maybe the pattern is odd numbers, 1, 3, 5, 7, 9. Maybe it's multiplied by 3, 1, 3, 9, 27. I don't have enough information, so I can't make a conjecture. We really have to make sure there's enough pattern that's happening in order to make a statement about what we're observing. So here's another example. This is really a pattern. What conjecture can you make about the next term in the sequence? So I see circles that go from orange, yellow, green, orange, yellow, green. So I'm going to guess, based on that pattern, the next term will be orange. Okay, there was enough information for me to make that statement. And then just be careful, not all conjectures will turn out to be true. So check them, test them. If you find one counterexample, vocab word, one false time that it happens, that it doesn't happen, that conjecture it's false now, okay? So just double check, make sure you have enough information, and if it's not true, then you'll have to re-observe, okay? Now that we talked about inductive reasoning, when we take in observations and make a statement, let's talk about deductive reasoning. Deductive reasoning is based off of definitions. Notice how I'm kind of giving you clues on how to remember it. Inductive, taking in observations. Deductive, definitions. So deductive reasoning uses facts, definitions, and accepted properties to form a logical argument. So deductive reasoning is based on facts, okay, and definitions and what we know to be true, okay. Triangles have 3 sides. things like that, using these definitions to make a logical argument. All we're going to practice here is comparing inductive and deductive reasoning. So let's determine whether inductive or deductive reasoning is used to reach the conclusion. So here's the first example. Each time Monica kicks the ball up in the air, it returns to the ground. So the next time Monica kicks the ball, it will return to the ground. This one, what do we think? This is actually inductive reasoning because it's based on observation, right? Somebody is observing each time, like, oh, hey, Monica's kicking the ball up in the air. Oh, it's coming back down to the ground. They're observing this happening, and then they're making the conjecture. Next time she does this, it will also return to the ground. Okay, here's another example. What do we think? All reptiles are cold-blooded. Parrots are not cold-blooded. Sue's pet parrot is not a reptile. Okay, and this is deductive, right? This is based on the definition of what cold-blooded means. Okay, so we're using facts, definitions, in order to say, okay, her pet is not a reptile then. Okay? Great job, guys. That's all we're learning about in section 2.2. Pretty short, 3 quick section vocabulary words. You guys rock.